Hello everyone, welcome to BYJU'S exam prep, and in this class we'll discuss some question on intermediate code generator and code optimization. Okay, so welcome you all once again on BYJU'S exam prep. Okay, so this is my Telegram link, my dear friend. If you want, you can join this Telegram link so that if you have any question, any update, fine. If you want any notes, you can definitely get from this Telegram group. And yes, so one more thing just I want to say, जिन्होंने भी नीलिट का एग्ज़ाम फिलअप किया हुआ है, फाइन, जिनका बहुत बेसब्री से इंतज़ार था नीलिट का एग्ज़ाम होगा कब, उसकी डेट आ चुकी है, फाइन. सो एग्ज़ाम की डेट आई थिंक इट इज़ 4th of November. सो आई थिंक यू हैव अप्रॉक्स 1 month. सो किसी के लिए भी ये ड्रीम जॉब होती है, फाइन. सो प्लीज़ ये लास्ट मंथ में आपको होप नहीं छोड़नी है, और प्लीज़ कीप ट्राई हार्डर, try to solve each and every problems which are which asked before also, and try to revise all your notes, because in NEELIT they will ask basic fundamental questions, not very tough questions, fine. So basic fundamental questions only. So if you have very good idea about all the subjects, definitely you are able to score good marks, fine. Definitely you are able to score good marks. So it's up to you if you are performing. If you have 1 month, my dear friend, please try hard. And one more thing, one help for you everyone, we'll try to provide you all NEELIT question with answer on YT and BYJU app, that is free only, fine. So if anyone want to attend the class, you can attend the class also on YouTube and BYJU exam prep app, and that is totally free. Okay. So okay, already we have done SDT. So just for the revision, I have taken this question, fine. So I have taken this question. So see clearly, S goes to DL and L dot type equal to D dot type, and D goes to int, D dot type equal to int, and L goes to L1 comma ID, L1 dot type equal to L dot type, and L goes to ID, fine. Let me write here, the last one is nothing but L goes to ID. L goes to ID. Okay, so yeah, can you please try? The last one is nothing but L goes to ID. L goes to ID. It is nothing but L goes to ID. Okay. So can you please tell what about this one? Just I want to ask. This is rule 1. You can say rule 1. What about rule 1? It is synthesized or inherited? It is synthesized or inherited. Can you please tell me? See here. L value you are computing in terms of their sibling, my dear friend. It is nothing but inherited. So here type is nothing but this one. You can say here in rule 1, type is inherited. Type is inherited. Fine. Just some revision. Inherited, fine. Inherited. Okay, fine. Now what about this one? D dot type equal to in. So see, parent value you are computing in terms of their children. So here type is nothing but, here type is synthesized. Is synthesized. Okay, synthesized. Okay, and what about this one? See, L goes to L1 comma ID, and L1 dot type equal to L dot type. See here, child value computing in terms of their parent. It is nothing but, here type is inherited. Is inherited. And I am not writing anything here. So see here. So this rule 1, you can say this, the first production is type is inherited. In the second production, type is what? Synthesized. And the third production, type is inherited. So what you can comment about this one? See, the overall SDT, what you can say? The overall SDT, what you can say, my dear friend? The overall SDT, what you can comment? You comment, my dear friend, it is neither inherited nor synthesized. Fine. The overall SDT I am asking about. The overall SDT, you can say neither inherited nor synthesized. Okay. And what about L attribute or S attribute? It is, it is inherited also, and it is what? And see clearly, inherited, and my dear friend, see clearly, here L value you are computing in terms of their left sibling, fine. Here it is synthesized. Here L value you are computing from the parent. So it is nothing but L attribute. If they will ask, it is nothing but L attribute SDT. L attribute SDT, fine. This is L attribute SDT. This is L attribute SDT. L attribute SDT, not S attribute SDT. Okay, Just for the, see, if you have any doubt here, see, once again I am telling here, already I told in the last class, those who have not watched my last class, watch previous 2 classes, you can watch. See, L value computing in terms of their sibling, and D is the left sibling. It is allowed in L attribute as dt. L attribute as dt, it can be synthesized and inherited, and where we have only one restriction, either it can take, child can take value from the parent or their left sibling. Fine. Okay, just for the revision, because we have finished this, you can watch my previous classes for SDT. Okay, now I am moving now to this one. See, which of the following is machine independent optimization? Fine, this is MSQ question, multiple select question, MSQ question. Which of the following is machine independent optimization? Can you please tell me? Machine independent optimization, anyone? Loop optimization, dead code elimination, constant folding, register allocation. Can you please tell me? I am waiting for the reply. Please reply. So MSQ question, I think everyone knows. Loop optimization, my dear friend, it is what? It is a machine independent optimization. Machine, it is MSQ question, my dear friend. Multiple select question. Fine. See clearly, it is a loop optimization is a machine independent optimization, my dear friend. Dead code elimination is also a machine independent optimization. Constant folding, it is also a machine independent optimization. Register allocation, this is, my dear friend, machine dependent. This is machine dependent optimization, machine dependent optimization. Fine. There are many more, if you know, there are many more, not this one only. Like use of addressing mode is also, you can say, machine dependent optimization, use of addressing mode. Flow of control execution is also machine dependent optimization. Fine. Use of machine idioms, it is also what? It is also a machine independent optimization. Machine independent optimization. Fine. So yes, you should know about this one. This is very easy one. Fine. In exam might be they will ask. You should be very prepared. See, we have 2 type of optimization: machine dependent and machine independent. So in machine independent, we have loop optimization, we have dead code elimination, we have constant folding, we have strength reduction, we have constant propagation. Fine. Is that clear? And in loop optimization, I think you know, we have loop invariant, we have loop unrolling, we have loop jamming. Fine. You should know about all those concepts that are very important. Okay. Can you please tell me what about this one? The optimization phases in a compiler generally reduce the space of the code or optimize the code to reduce execution time. This is MCQ only. Both A and B and neither A nor B. I think this is very easy question. So if optimization, you know, like reduce the space of the code, yes, and it will also what? Optimize the code to reduce execution time. So A and B both actually. So here C they have given, it is MCQ question, so you'll go with C option because both are correct. Both are correct, my dear friend. Fine. Both are correct only. Both are correct only. Is that clear? Both are correct only. Because with the help of loop optimization, what we'll do? Definitely we'll what? Optimize the code to reduce the execution time. Fine. Is it clear? And also we reduce the space of the code also. Fine. To remove some temporary variable and all. Is that clear? Okay. Now, which of the following is not a machine independent code or code optimization technique? Which of the following? These kind of question will come in nail it, definitely, my dear friend. Like simple question they will ask. If simple question, अगर आपने nail it का exam fill up किया हुआ है, they will ask simple question only, and if you are comfortable, definitely you are able to give the answer. So loop optimization, it is nothing but, you know, machine independent. They are asking not a machine independent. Sometimes we will not see not. They are asking about not a machine independent. See, loop optimization, my dear friend. Loop optimization is a machine independent. Folding means constant folding. I am talking about constant folding. Fine. Let's suppose if I am giving you 2 plus 3 through into 4. So you fold this 4 into 3. Fine. Then 2. It is nothing but, you know, like 3 into 4, 12 plus 2, 14. So this is nothing but constant folding. See, so loop optimization, folding, constant propagation, all are what? See, machine independent. Fine, this is what, my dear friend, not machine independent, peephole optimization. It is nothing but machine dependent optimization. See the class notes. This is machine. See the class notes I have shared in the group. Machine dependent. This is machine dependent, my dear friend. Okay. Let me move quickly. Okay. How many temporary variables are needed to write the 3 address code for the expression? Okay. कोई ऐसा है जिसने नीलेट का पेपर फिलअप किया हुआ है और वो 4th of November को एग्जाम में आप पार्टिसिपेट करेंगे? So please let me know. So what I will do, I will take session on like NILIT previous year and some important question based on NILIT. I will try to help you to score good marks so that you are shortlisted for the interview. Fine, because only qualifying criteria is not necessary. Final cutoff में आपका नाम आना चाहिए, and I want to see all those names who are attending the class. Fine. So if you want, please ping me here. Please ping me here. Okay. See, a plus b into c plus d. You need to find how many temporary variables are needed. So a plus b into c. So what you do? What? T1 equal to what? B into c. B into c, my dear friend. Find b into c. How many temporary variable it is needed? Minimum 2 you can do. Minimum 2. Okay. How many temporary variables are needed to write the 3 address code for the expression? Okay. Let me write here. So what we have, we can write here. Okay. Minimum you can 2. Okay. Someone telling 3 also. Okay. Let me write here. So T1 plus D I am writing in T2. And my dear friend, T2, A plus T1 I will write in A plus T1 I will write in T3. So how many temporary variable? How many temporary variable are needed to write the 3 address code for the expression? So T1 equal to B into C and T2 equal to T1 plus D and T3 equal to A plus T1. Okay. So this is, see, I have written here. Can you minimize this? Can you minimize this? Can you please tell me? Can you minimize this? I'm not talking about a static single assignment as of now. I just want how many temporary variables are needed to write the 3 address code. 3 address code, everyone know. At most, in a line we have at most 3 variables. Fine, 3 addresses. At most 3 addresses. So here we have 3 addresses. Here also we have 3 addresses. Here also we have 3 addresses. So it is in 3 address code. But can you minimize this? Can you minimize? Okay, let me write here. B into C I am writing here. It will go into the T1. Okay. Now I am writing here, see clearly. You can write if you want. If you want, see clearly. T1 plus D. T1 plus D. T1 plus D, my dear friend. I will write. Can you write in T1? Can you write in T1? Is there any problem? T1 plus D, can you write in T1? Can you write in T1, my dear friend? Fine, no problem. Now the result of T1 I will add to A. T1 plus A and I will put into T1. So with the help of 1 also you can able to do. But see, they are not asking about minimum. How many temporary variable are needed to write the 3 address code? So the answer you will go with C. C. Fine, C is 3. 3 you can go. 3 you can write. Even though my dear friend, see, if they will ask about a static single assignment, I think, you know, in left hand side you can use only once. You can use only once. So this result should be go into T2. Should be go into T2, my dear friend, and this T2 plus A should go into the T3. So now 3 variables. So according to static single assignment, maybe 3 will be the answer, but they are not asking about minimum here. So yeah, you can go with 3, no problem. Even though you can do with 1 also, fine, but 1 also, 3 address code you can do with 1. Is that clear? Please reply. Am I clear here? Or if you have any doubt, you can ask me. Please reply, my dear friend. Clear? Okay. So with static single assignment, answer will be 3. Okay. I am moving now. Okay. Can you please try? What is the minimum number of temporary variable required to create 3 address code in static single assignment form if the expression is given this one? 3 address code का मतलब क्या होता है? See, in a line we have maximum 3 variables, at most 3 variables, fine. And static single assignment का मतलब क्या होता है? Once see clearly in just in left hand side, see if you use any variable in left hand side, it will not use further. It will not use further, my dear friend. Fine. It will not use further. Like this one. See, let me try this one. C into D. See, I am writing in T1. Okay. Let me do this. E by F. I am putting in T2. No problem. Now see clearly H by I am putting in T3. Okay. Maybe you do in different way. Now what I am doing here, it is nothing but see G into H by I. See, I cannot use, if I use T1, I cannot use in left hand side anymore. Are you getting my point? T1 you cannot use in future. In future in left hand side. In right hand side you can use any number of time, but in left hand side you can use only once in static single assignment. Now G into HI, so I need to take T4 my dear friend. Now what we have, can you please tell me? Now what we have? Yeah, can I write this one? Now what I have this one, C E by F, it is nothing but T2 into T4. I will write in T5. I will write in T5. Okay. Now what about this one? Now it is nothing but this C into D minus C into D means this one T1. So T1 minus what I have T5. I will write in T6. What we have? A plus my dear friend, A plus T6, I will write in T7. So how many variables are required? Can you please tell me how many variables? See, 7 variables. Static single assignment में इतना ध्यान रखो बस कि लेफ्ट हैंड साइड में वो वेरिएबल एक ही बार यूज होगा, राइट हैंड साइड में वो कितने बार भी यूज हो सकता है. जस्ट सी लेफ्ट हैंड साइड में वो एक ही बार यूज होगा स्टैटिक सिंगल असाइनमेंट के अंदर, नॉट मोर देन 1. तो यहाँ पे कितने वेरिएबल लगेंगे? यहाँ पे 7 वेरिएबल लगेंगे, यहाँ 7 वेरिएबल लगेंगे. ठीक है, इज दैट क्लियर? 7 वेरिएबल आर रिक्वायर्ड हियर. 7 वेरिएबल आर रिक्वायर्ड हियर. 3 एड्रेस कोड का मतलब समझ लो, इन अ लाइन वी हैव मैक्सिमम 3 वेरिएबल, एटमोस्ट 3 वेरिएबल, एटमोस्ट 3 एड्रेस. फाइन, एटमोस्ट 3 एड्रेस. 3 एड्रेस को रिप्रेजेंट करने का तरीका पता होगा ना? ट्रिपल होता है, इनडायरेक्ट ट्रिपल होता है और क्वाड्रपल होता है. फाइन, 3 तरीके होते हैं. ओके, हाउ मेनी मिनिमम वेरिएबल्स आर रिक्वायर्ड in equivalent 3 address code for the above static single assignment code? Can you please reply? How many minimum variables are required in equivalent 3 address code for above static single assignment? Good evening Satya. Can you please reply this question? Good evening. What is the answer for this one? I am waiting for your reply. How many minimum variables are required in equivalent 3 address code for the above static single assignment? If you see clearly, there is no meaning of this one. You can remove this. Now you can try. There is no meaning of this one. Fine. In the question, if you see clearly, so you can write this one is nothing but T1 equal to A minus B, T2 equal to T1 into C, T2 equal to T1 into C, my dear friend. And what we have, this is nothing but T1 by T2, and I am writing in T3. So what is the answer? 2 कैसे होगा? How you can write in 2? How you can write in 2, my dear friend? Can you please tell me? 3 will be the answer. 2 कैसे आएगा? See, this one T3 equal to A minus B, my dear friend. You can remove this. See clearly, you can remove this. No need to once again A minus B put into T3. It is same. A minus B value does not change here. It will not change here. Are you getting my point? So this one A minus B input in T1. Now T1 into C will put in T2. Now this is nothing but see T1 only. So T1 by T2 will put in T3. Fine. So answer will be what? 3. 3 will be the right answer. See clearly, in left hand side, my dear friend, see, it will use only one time. In right hand side, you can use multiple time, no problem. You can use multiple time, no problem. In left hand side, you can use only one time. Okay, I am moving now to the next question. Okay, this one. Consider the Consider the below statements. Intermediate code can be represented using syntax tree. Intermediate code can be represented using directed acyclic graph. Intermediate code can be represented using postfix notation. What is the answer for this one? Can you please reply? What is the answer for this one? If you have any doubt in previous question, you can ask. So intermediate, my dear friend, intermediate code representation. Intermediate code representation. I think everyone know. There is nothing but we have a linear form and we have a non-linear form. See the notes only. Fine. All thing is there. I'm not telling everything here. Fine. So linear form and non-linear form. In linear form, what we have? In linear form, what we have? We have, my dear friend, can you please tell me? In linear form, what we have? Anyone? कौन बताएगा? Satya, everyone please tell me. Yeah, someone already given the answer. Someone given already the answer. All are true. Last option is all are true. If it is not visible to you, okay. We have postfix. Everyone know. We have postfix. We have 3 address code. We have static single assignment. And in non-linear, what we have? In non-linear, what we have? What we have? We have DAG and we have syntax tree. We have DAG and syntax tree. Okay, very good. So intermediate code can be represented using syntax tree. Yes, true. Intermediate code can be represented using DAG. Yes, true. Intermediate code can be represented using postfix notation. Yes, true. So all are true. D for Delhi is the right answer. D for Delhi is the right answer. Very good. Very good. Keep it up. Very good. Okay, I am moving now to next question. Okay, can you please try this one? Control flow graph. If you know about basic block and if you know about leader and all, you are able to solve this problem. Please try to solve this problem. Please try to solve this problem. Please try to solve this. The number of nodes and edges in the control flow graph constructed for the above code respectively are x and y. The value of x plus y edge. Don't include start and end nodes and edges. For start and end nodes for edges. Fine. Don't include start and end nodes. Fine. Start and end nodes don't include. Okay. In nodes, my dear friend, start and end don't include. For nodes also and for edges also, they are telling here. I think everyone knows. See clearly. I think anyone want to give the answer? Anyone want to give the answer? See. So see clearly what is the basic block. I think everyone know. If you see my notes, see, first statement is always a leader. This is always a leader. Okay. First statement is always a leader. See, go to 3. This is nothing but conditional jump. If A equal to B, go to 3. So 3 is always a leader. 3 is always a leader. Fine. And see here, followed statement. See, after 6, if any statement is there, it is also a leader. But see clearly, after 6, no statement is there. After 6, no statement is there. Fine. So now we have 2 leaders here. If someone asks how many leaders, we have 2 leaders. We have 2 leaders, my dear friend. How to find a leader? First statement is always a leader. And see here, conditional or unconditional jump. Target of conditional or unconditional jump is always a leader. So if A equal to B, go to 3. So 3 is always a leader. After 6, if any statement is there, it is always a leader. No statement, no problem. Now, what is the basic block? So first leader to next leader. Before next leader, it will be one basic block. So this is one basic block. This is one basic block. Fine. And see clearly, till 3 to 6 is one basic block. Okay. 3 to 6 we have one basic block. Please tell me, it is one basic block. One basic block. Now my dear friend, everyone know we have a start here, start node, start, and here we have an end. Let me end. I'm writing here end. It is visual for everyone, end. Start and end. So let me just clear it, and here this is end and this is what? Start. One arrow is here. One arrow is here, my dear friend. Can you please tell me? Okay, let me change one more color for you. Let me take red if it is visible. See clearly here. So 2 nodes and 2 edges they are telling. 2 nodes and 2 edges. Okay. 2 nodes and 2 edges. Okay, fine. So here what? Go to 3. 3 is only here. So there will be a one edge. Self loop is here. Fine. Self loop is here. And one is edge here. One is edge here, my dear friend. Is that clear? One is edge here. Fine. So in this question, my dear friend, in this question, they have clearly mentioned don't include start and end as a node and as the edges also. Fine. Don't include it. So how many basic blocks? See how many nodes we have. See, one basic block and we have 2 basic blocks. So node means node. Don't count start and end. So that's why x is what? X is what? 2. X is what? 2. Very good. Now my dear friend, what is y? Y is what? See, edges. See the red one. This is the first edge. This is the second edge. We have 2 edges. Blue also we have the edges, but they are asking here. They have clearly written don't include start and end edges also. So it is nothing but 2. So 2 plus 2 will be what? 4. 2 plus 2 will be what? 4. So answer will be 4 for this one. Answer will be 4 for this one. 4 is the right one. I think someone has given the correct answer. So 2 plus 2 equal to 4 is the right answer for this one. Okay, if anyone have doubt, let me just give you this question. Fine, can you please try this one? Okay, everything can you please try? I ask you here, number of basic block, please find out. Number of basic block. How many number of basic block? Please find out. Number of control lines. Control lines. Number of, you can write number of edges and number of nodes. Can you please try in this question? In this question, can you please try? Number of basic block, number of control, number of edges and number of nodes. Because you should differentiate between all basic block, control, edges and nodes. You should know about this basic concept, otherwise you do wrong. See clearly here. So first statement is always a leader. This is a leader. Fine. Okay. Now see clearly, go to 5. This is what? Conditional jump. Go to 5. So 5 is a leader. Followed by this one is also a leader. 4 is also a leader. Go to 10. So 10 is a leader. After this one is always, see, this one is a leader. Yes, it is a leader only. Fine, no problem. Now go to 3. So 3 is also a leader. And after this one is also a leader. Fine. I think you got the leaders. You got the leader. So you can write here how many leader we have. Maybe in the question they will ask number of leader also. So 1, 2, 3, 1, 2, 3, 4, 5. So we have 5 leader. We have 5 leader, my dear friend. We have 5 leader. No problem. No problem. Fine. Now just draw the basic block. So basic block, let me write here. So we have, see, we have start first, start. And I'm writing, now we have what? See here, 1 to 2. 1 to 2 in one basic block. Okay, 1 to 2 in one basic block. And my dear friend, we have 3, see, 3 in one basic block. 3 in one basic block. 3 in one basic block. 4 in one basic block. 4 in one basic block. And 5 to 9 will be in one basic block. 5 to 9. Please correct me if I am wrong. Fine. 5 to 9 in one basic block. Fine. And 10 in one basic block. 10 in one basic block. Okay. Okay. Now if you see clearly here, just you should know about this one. If you see clearly here. So and what we have, let me write here end also. End. Fine. And let me just draw this one. This one is I am taking is red color, and this one also I am taking as a red color. Okay, red color. Now please draw the edges. See 1, 2, after 1, 2 can I go to 3? Yes, I will go to 3. So see one edge. Let me change the color. So 1, 2 to 3. Fine, 1, 2 to 3. See if I less than x, go to 5. So there will be one edge here. 1, go to 5. If it is false, it will go to 4. One edge will be here. Fine. If I less than x, go to 5. Otherwise, if it is false, if it is true, it will go here. If it is false, it will go here. Okay. Now 4, go to, see here, 4, go to 10. So there will be no edge. Directly will be edge from here. Go to 10. Fine. It will go to 10, my different. Go to 10. Fine. because no condition. Go to 10. Now here see 5 to 9. Now what we have? 5 to 9. And what? Go to 3. 9 to what? We have one more edge. Let me write here. Let me erase this a little bit. What we have? So go to 3. Go to 3. So we have this one. Go to 3. And anyhow, and we have what? 4 to 10. So we have 4 to 10. Anyhow, we can draw 4 to 10. Okay, 4 to 10. Fine. 4 to 10 we have. I think we have done. We have done. So number of basic block. How many number of basic block? Can you please tell me? Number of basic block, how many we have? So basic block you can say, see clearly, 1, 2, 3, 4, 5. 5. So basic block, now what we have? 5. Okay. Basic block we have 5. Okay. Number of nodes. So you can count all the nodes. See, generally if they will ask nodes, so we have 1 means 5 and plus 2, 7. So 7. 7 is the number of nodes. Okay. Number of control. So number of edges, how many? See clearly. Just see the blue lines. Blue lines is the number of edges. So 1, 2, 3, 4, 5. So this is nothing but 5. Number of edges. Number of control you can count red line also. Blue plus red line. It is nothing but 7. Fine. Yes, notes में include करते हैं. अगर कुछ नहीं लिखा है, you can include this. If it is not written, you should include. If it is not written, you should include, my dear friend. Okay. If it is not given, you should include. If they are mentioned, you don't include start and end node, then you will not include. Okay. If it is mentioned in the question, then you will not include. What you are asking? Edges. See edges. See here, number of edges here will be 1, 2, 3, 4, 5. 5 edges. Number of controls, if they will ask, you can add. I think something I have written wrong. Yeah, edges, I think I have written wrong. Fine, sorry for the mistake. This is 7. You can count all 7, and this should be 5. This should be 5. Sorry for the mistake. 1, 2, 3, 4, 5, and 6, 7. 7 total edges. Starting, ending also you count. Number of controls is 5. Number of controls is 5. Okay. Sorry for the mistake. Number of edges 4. Number of edges you should count all. Therefore, if someone have doubt, see number of basic block, my dear friend. See rectangle 1, 2, 3, 4, 5. Okay, number of basic block. Number of basic block clear? Just rectangle. See basic block. Okay. Now number of controls means, see here, control means these blue lines. These blue lines are control. 1, 2, 3, 4, 5. So 5. Number of edges, all edges. All edges. Number of edges means all edges. So 5 and 2, 7. And number of nodes, all. Basic block plus starting and ending. Basic block plus starting and ending. Is it clear? Basic block plus starting and ending. Basic block is starting and ending. Is that clear? Please reply. Okay. Now if it is clear, you can try this question. You can try this one. Can you please tell me what is the answer for this one? Now same thing. Number of basic block, number of controls, and number of nodes, number of edges. What is the answer for this one? Number of basic block, number of control, number of nodes, number of edges. So I am trying this one also. So this one is a leader. This one is a leader. Okay. No problem. This one is a leader. This one is a leader. This one is a leader. Now go to 8. So 8 will be leader. 8 will be leader. Go to 8. 8 will be leader. Followed by this one, 6 will be a leader. Go to 10. 10 will be leader. Go to 5. 5 will be a leader. Followed by this one will be a leader. I think yes. We find all the leaders. Now my dear friend, find the basic block. So we know we have a start, and we have what? End also. You know. So 1 to 4. 1 to 4. It will be in one basic block. 1 to 4. 1 to 4. Now 5 will be in one basic block. 5. Okay. 5 in we have one basic block. And what we have? We have 6, 7. 6, 7 we have in one basic block. 6 and 7. And we have 8 and 9 we have in one basic block. And 10 we have in one basic block. And now we have what? We have what? Exit. Exit. Okay. So yes. So let me tell you, this is also very simple one. So yeah, let me write red color. This is red color. This is red color. Fine, for the clearance. Okay. Let me write the now 1 to 4. So after 4, can I go to 5? Yes, I can go to 5. No problem. So there will be an edge. If T1 less than 6, go to 8. So I will go to 8, and it is true. If it is false, I will go to here. If it is false, I will go to here. Fine, no problem. If it is false. Now A equal to B into D. So and 7, go to 10. So I will directly go to 10. So edge will be here. Go to 10. And 9, go to 5. So go to 5, edge will be here. Edge will be here. Okay. So don't bother about the program. Maybe they will stuck in loop. But can you please tell me what will be the answer? Now, number of basic block, rectangle. 1, 2, 3, 4, 5. So 5 is number of basic block, 5. Okay. Now number of controls. Number of control means these edges only. Basic block edges means blue line. 1, 2, 3, 4, 5. So this is also 5. This is also 5. This is also 5. Fine. Why 6, 7 in the same group? Because why 6, 7 in the same group? Because see, leader to before the next leader. That's why. See, leader to before the next leader. That's why 6, 7 will be in one group. Are you getting my point? Leader, because 8 is a leader. So basic block is nothing but leader to my dear friend before the next leader. So 6, 7 will be in one group. Okay. So 5. Okay. Number of nodes. Number of nodes you can add just to 7. Number of edges you can add to 7. Fine. If you have doubt, you can ask me. If someone have doubt, you can ask me. See, basic block is nothing but first leader before the next leader. It will be in one basic block. So 1 to 4 in one basic block. See, 5 is a leader, 6 is a leader. So 5 will be in separate basic block. Now 6 is a leader, 8 is a leader. So 6 and 7 will be in one basic block. Now 8 to 9 will be in one basic block and 10 will be in one basic block. So see clearly, it is nothing but this is the control flow graph. And basic block means rectangle here. See, just I have to mention basic block, I have mentioned in rectangle. See, this is basic block 1, 2, 3, 4, 5. 5 basic block. Control means these blue lines is the controls. Nodes means you can count all. If in the question they have not mentioned, count all. Starting and ending also you need, starting and exit. Starting and exit you need to count. So 5 to 7. 5 to 7. Edges, count all. Count all 7. Count all 7. Is that clear? Please reply. Fine. I think it is visible now. Visible or not? Is it visible? Okay, fine. Means like this 8 statement I am feeling it is not visible. I am seeing in my mobile. I think might be you are struggling. Okay. Okay, fine. No problem. So we have solved some question already. Fine. So be careful while solving the question. Here in the question they have mentioned don't include start and end notes and edges. Fine. In the question they will mention you. Or can you please tell me what is the output? Consider the following below DAG. What will be the output? What will be the output? Can you please reply? What is the output here? कोई भी नीलिट का अगर फॉर्म इधर फिलअप किया हुआ है मुझे बताओ आप लोग. नीलिट का फॉर्म हम लोग नीलिट के लिए जो भी प्रीवियस ईयर क्वेश्चन है और जो भी इंपॉर्टेंट क्वेश्चन है विल स्टार्ट. एंड आई विल स्टार्ट इंपॉर्टेंट टॉपिक्स ऑल्सो. लाइक इफ यू आर स्ट्रगलिंग इन सिंक्रोनाइजेशन आई विल टेक सिंक्रोनाइजेशन पोर्शन. इफ यू आर स्ट्रगलिंग इन memory management or any subject, any topic, please let us know. NIC का प्रीति डेट आ गया क्या एग्जाम का? नीलिट का तो आ गया है, नीलिट का डेट आ चुका है. व्हाट अबाउट NIC? अभी नहीं आया. ओके, मे बी इट विल कम सून. What is the answer? Can anyone say? This is very simple question. So what it will compute? 5 plus 4 into 3. So 5 plus 4 into 3 is nothing but 12 plus 5. It will compute 60 here. It will compute, yeah, 170 is the right answer. It will compute 60 here. 5 plus 4 into 3. 60 here, fine, because 5 you can write here 5 plus 4 into 3. So 12 plus 5, 5 plus 4 into 3. 12 plus, it is 17, sorry, it is 17, not 60, it is 17. It is plus only, yes. So 5 plus 4 into 3, and here it is nothing but 4 into 3 minus 2. It is nothing but 12 minus 2, it is nothing but 10. So this is nothing but 10. And 70 into 10 is nothing but 170. So 170 is the output. 170 is the output. Okay. Okay, can you please try this one? Find the minimum number of nodes and edges in equivalent DAG for the given expression and given the value of x plus y. What is the answer for this one? A plus B into C minus D into E. What will be the answer for this one? Can you please reply? What will be the answer? I am waiting for the reply. Please give me the correct answer. I think you can do this. Fine, it is easy one. You can try. If you have any problem, you can ask me. It is easy one. Okay. If someone have any problem, you can saw my notes. You are able to solve the problem. So okay, you can try this one. You can try this one. Or yeah, you can try this one. Consider the intermediate code given below. The number of nodes and leaders in the control flow graph for the above code written without spaces and in order. Fine. Can you please tell me what is the answer? I think you are able to give the answer for this one. You can try. See, this is nothing but k equal to 1 first statement. It is a leader. Fine, it is a leader. Go to L1. So L1 is a leader. L1 is a leader. Go to L2. So L2 is a leader. After L1, this one is the leader. Fine, this one is the leader. Are you getting my point? And what we have, yeah, anything more we have? No. Fine, I think you can easily find out. You can easily find out here, and they are asking about number of nodes and number of edges. Number of nodes and number of leaders. So leader, I think 1, 2, 3, 4. 4 leaders we have. 4 leaders we have. 4 leaders we have, and nodes you can count. Nodes, how many nodes we have? I think you know. If they have not given, you can count start also. Start, and I am writing here. I am writing here k equal to 1. Fine, and s equal to 1. And L1 to this one. This one will be a 1 leader. 1 node. So 3. And Yeah, this one will be a next one. So I think you know how, what is the answer for this one? What is the answer for this one? We have 1 and we have end also. So 1, 2, 3, 4, 5 and we have end also here, end. Fine, end also. So we have 1, 2, 3, 4, 5, 6. 6. So 6 notes and we have 4 letters. Am I right? Can you please cross check? 6 notes and 4 letters. I'm not drawing all control flow graph here. If you want, you can draw, but yes. Is that clear? Please reply. This question is clear? Fine. If you have doubt in this question, you can ask me. You can try this question also. The intermediate code generated for the given syntax tree. So you know intermediate code. I am giving the hint for this one. It will be a postfix. You know, intermediate code representation. You know, you can represent in the form of postfix. So infix will not be the answer. So this one and this one cannot be the answer. You can now you have option with A and C. Now you can try this one. You can try this one also. Fine. You can try this one also. Consider the following code segment. The minimum number of variables required to convert the above code into the single static assignment. This is very easy. I told you how to convert. See, you can just take x1, this one, x1. Let me take x1 equal to u minus t. Now y equal to what? X1 into v. Fine. Y, this is y1 you can take. Now what we have? Y1 plus w, you can write x2. No problem. Now what we have? This is t minus z. So I can write here y2, y2. Now this is nothing but see. This is nothing but x2 and this is nothing but y2. I am writing here y3. So can you please tell me the minimum number of variables? So 1, 2, 3, 4, 5. So answer will be 5. Can you please cross check this one? Can you please cross check? It is easy. See, clearly I told you left hand side we can use only one time. You can use only one time. So this is nothing but you can write here x1, y1, x2. See x1, y1, x2, y2, y3. So here we have 3 to 5. So minimum number of variables required to convert the above code segment to the static single assignment form. I think 5. You can cross check once. Is it so? Yes, 5 only. Very good. Now, like that you can try for this one. This is also a static single assignment. Fine, you can try. This is also easy one. You can try na p equal to a minus b. Now you can write this is p1 into c. You can write this is q1. This is p, you can write p1. So p1 into c. Now p1 q1 you can write. Now this is nothing but p1 into u into v. And this is nothing but p1 and this is nothing but q2. Now you can check. Fine, it is easy only. So yeah. You can try DAG for this one. This is also simple question. Okay. So I think we have done all. Fine. So we have not done live variable problem. So I will take one separate session on live variable. Fine. But please tell me here. Please tell me now onwards. If anyone from nail it. Fine. If you have exam on 4th of November, please let me know. Fine. And if you want any specific portion for GATE also, please let me know, so that in October I will plan accordingly for you. Fine. And I want to give you good content and good quality also, so that like you can express more in your exam. Fine. You will like outcome will be good in your exam. Fine. I don't want to like if you are studying in my class, fine, definitely you will be feel happy in the exam. You will be feel happy in the exam. So please let me know, my dear friend, if you have any doubt, any concern, if you want any particular topic questions also. But yes, I told you very clearly, yes, live variable I will take one separate session. That's why I have not taken it as a new session, and I will take live variable plus live variable problem. Fine. So in this question I have not taken intensely, but yes, I will take a separate session on live variable. So live variable इसके अलावा और भी कुछ, because NAILIT के बहुत सारे students हैं, they are querying to take some previous year questions of NAILIT, some important question on NAILIT and GATE also. So I will take accordingly. You can ping me in my Telegram link also if you want. In my Telegram link also. Please reply. And some like 2-3 questions you need to solve. Already I have given this in PPT. You can please solve. If you have any query, you can ask me in my Telegram channel. Please reply. Is that okay? Okay, then I'm leaving now. Hope everyone. Machine dependent optimization concept extended question. Okay. Machine dependent optimization concept and expected question. Okay, I will take. You can write in the chat box so that I will take a screenshot and I will try to make more good question based on that concept. Like someone is asking machine dependent optimization concept and expected question. Fine. Like that, someone have written live variable. You can please write here. Whenever I will get time, I will take some classes based on that. You are late, Preeti. That's why it is happening. You please see the lecture. Fine. See the lecture. Fine. Definitely you are able to understand. See, if you know about control flow graph and little bit about optimization, fine, you are able to solve. See, that's why for being a teacher also, it is a problem if someone has not covered the concept. If you have already covered the concept, for us it is very easy to explain the concept. Fine. But if someone don't know what is DAG, what is tree address code, what is static single assignment, what is control flow graph, what is basic block, fine, and what is in basic block, how you can find the leaders, fine, how you can write, how you can say like which statement will go into the particular basic block. Yes, so you need to be, please, I think if you are in my Telegram group, I have already shared the notes. You just please watch that particular code optimization chapter and followed by this video, you are able to understood every concept. Okay. Okay, and if you have any query, you can ping me on my Telegram link and here also. Thank you so much and take care of yourself and be healthy, my dear friend, because for preparation you need to be very energetic, very energetic. Fine. Okay, so thank you so much. Good night. We'll meet you soon. Stay tuned on BYJU'S Exam Prep YouTube channel as well as BYJU'S Exam Prep channel also, on BYJU'S Exam Prep also. Fine. Okay, thank you so much. We'll see you.